So thanks a lot for coming to this talk, preparing for a future microservices journey. In November 2010, Thomas Thwaites, a designer from the UK, gave a really funny TED talk about his project that he accomplished before. And his project was called the Toaster Project. And it was about his idea to build a toaster from scratch. So he went to his local appliance store and bought a very cheap toaster for re-engineering purposes. And he started to disassemble it. And he was very surprised that this very cheap toaster, £3.94, was consisting of 404 different parts made of 100 plus different materials. Since he didn't have his entire lifetime to spend on this toaster project, he was focusing on 5 of them: steel, mica, copper, nickel, and plastic. And he went out on a quest for all these materials. So he was traveling to a remote iron mine in the north of England, and he came back with a suitcase full of iron ore to extract steel from. He also was trekking to the highlands of Scotland in the search for mica. And his entire journey to build this toaster from scratch was paved with a lot of failures and setbacks. But finally, after 9 months, he managed to finish his toaster to build from scratch, and the result looked like this. So why am I telling you this story about this toaster project? Because it reminded me somehow, with all the challenges that come when transitioning your monoliths going from monoliths to microservices. So it starts with your beautiful, tiny, independent, small microservice that is modeled around your business capabilities, that is reflecting bounded context where your domain model lives in. And you start to extract it or service by service from your monolith. When you do this, so every microservice itself needs to store the state of their domain model. So we need to address some data storage components. It has to be deployed on some kind of servers, preferably packaged as a container. It needs to provide an API for communication purposes. We need service discovery to which each service is registered to and can be discovered by other services to connect to. In case of multiple instances are running of our services, we need a load balancer that distributes the traffic and the workload. Since our microservices are now communicating over a slow and unreliable network, we have to design for failure to keep our system resilient, introducing stability patterns such as timeout handling and retries to recover from failure and to repeat an operation that has timed out. With retries, we have to make sure that our operation are idempotent, so that its repeated call is leading to the same outcome. And to preserve partial functionality when a failure occurred, we have to consider bulkheads. To protect our system against cascading failure, a circuit breaker can help us to isolate the failure. For event-driven service communication, we need to consider to introduce some kind of message broker where our services can publish and subscribe messages to. An API gateway provides a single point of entry from the outside. And since our services are not only consisting of code, but also of configuration data, we have to make sure to provide a centralized configuration management. We need to consider observability to generate a deep understanding of the health of our system. We need a Git repo and a CI/CD pipeline per service. And we need to consider backup and recovery in case of our services are failing. So, to create one service, you have to consider a lot of infrastructure and operational complexities. And if you have to take care of these infrastructure and operational complexities all by yourself, and you're a small team with little DevOps practices in place, that bears the risk that you shift the focus away, that you shift the focus from building your business domain to handling all these infrastructure complexities. And if you're a small team with little DevOps structures in place and you have to meet sharp timelines, and you still have to take care of your legacy system, you might end up with compromises on things that you should not compromise. You might end up with a product that could look like this. So this is a product which took a very long time to build, is very expensive, and in this case even not usable, just only for 5 seconds before it was melting down because of missing installations. So now the question is, how can a small team handle infrastructure complexities and deliver a user and business value at the same time? And the short answer to this is that we need to focus on our core domain that gives us a competitive advantage and offload the undifferentiating commodities to someone else. So we need to shift the focus back from handling the infrastructure complexities to build the core domain that is fulfilling user needs, which generates visible user value and leading to satisfied customers. So the core domain is the one that we should strategically invest most. That's the one that we should build in-house. And to shift the focus back to our core domain, we need to offload the commodities. For example, by outsourcing commodities that are not differentiating us from our competitors to utility suppliers. And this helps us to decrease the delivery time for new features, or that helps us to increase the software delivery performance and fulfilling business needs. So software delivery performance has a strong impact on profitability, productivity, and market share of technology organizations. And it's really critical for technology organization to focus on software delivery performance and to do business today. Just a quick introduction to myself. So who am I? So I am Susanne Kaiser. I am from Hamburg, Germany, and I am an independent tech consultant and supporting organization tackling complexities from software architecture to software delivery. And I was previously working as a startup CTO and transforming their SaaS solution from monoliths to microservices. And I do not only talk at tech conferences as a speaker, but also I am involved at many tech conferences as well as a co-organizer or a program committee member or track host. So, for example, Microexchange in Berlin, and that's a microservice and serverless conference in Berlin. Then serverless days in Hamburg, and also MicroCPH, that's a microservices and serverless conference in Copenhagen, and QCon New York, that's happening then, I guess, in 2 weeks. So now coming back to the question, so how can we identify what to build in-house that is generating user value and what to outsource that is generating business value? And that's something where Wardley maps come in. So who of you have heard of Wardley maps before? Excellent, that's something new to you. Great, fantastic. So Wardley Map has been created by Simon Wardley. He's a researcher from the UK, and he has created this technique. And it's the Wardley Map is a representation of the landscape a business is operating in, and allows to visualize the evolution of a value chain. So what is a value chain? It's behind every user need there is a value chain, and starts off with a question: who are your users? Who are going to you, approaching you to searching for help? And what are their user needs? So what is their user journey? What kind of problem they would like to get solved by you? And what are the components and activities that fulfill these user needs, either directly or indirectly facilitating other components in the value chain? So, and what are the position in this value chain of these components? For example, you have on the top, you have those components where users are touching your system directly, and at the bottom, you have those components that are less visible to your users. So we take this value chain and plot it along an evolution axis, and going from left to right, going from left, Genesis and the brand new things, to custom build, to product and rental, for example, off-the-shelf products and open source software, and to commodities. And the movement of a component from left to right is determined by its stage of evolution. And so the evolution, it's never static, it's very dynamic. So everything evolves from left to right through the forces of demand and supply competition. And while the components are evolving from left to right, the characteristics change from the uncharted, undefined, unpredictable, constantly changing domain to the right, to the industrialized, well-known, well-spread, commonly understood domain on the right. And there's no choice over evolution, so you have to continuously adapt, otherwise you can be easily overtaken by others. And there's also that efficiency enables innovation. That means that, for example, the industrialization of one component enables the innovation of others. So it could also that the industrialization of one component enables new features of an existing product to appear, or that other components can co-evolve, or that new components can emerge. And it's the genesis of new components that enables new user needs and creates future source of value. But there's also something holding you back to evolve your components, and this is inertia to change. And success breeds inertia. So any past success with a component tends to create a resistance to change that component. And the more successful you are with a component, the more reluctant you are to evolve, to let this component evolve. And there's also the case that inertia can kill an organization. For example, it was not the lack of innovation that, for example, Nokia was harmed by. In fact, they were very innovative. So in 2005, they came out with their smartphone 2 years before Apple came out with their iPhone. But the problem was that they underestimated the importance of evolving, of transitioning to the smartphone era because of their past success with their old cell phone model. And so they underestimated how important it was to transition to the smartphone era. And within 6 years, their market share declined by over 90%. So now that's enough with all the patterns. Just dive into a concrete example. For the concrete example of a conference solution, something that you as an entity has already interacted with. So how can a conference solution look like? So you might have different user groups like you as attendees or speakers or conference organizers, but just let's focus on you as attendees. So you could have the user needs that are related to the schedule. For example, browse the schedule by day, or filter the schedule by topic, or mark the session that you would like to attend to create your personal schedule itself. Or speaker-related, like list the speakers, or get the speaker details, or search the speakers by name. And also feedback-related in terms like marking, rating a session, or providing feedback to the conference organizers by filling out a survey. Or ticket-related in terms of like buying the ticket, printing the ticket, and getting the invoice. And those components that are fulfilling these user needs directly could be schedule management, speaker management, session rating, survey platform, ticketing platform that your users are communicating or touching directly with, interacting directly with. And each of these services have to save their domain model. So each of the services are requiring a data storage component which is less visible to your users. For searching the speakers by name or filtering the schedule by topic, you might need a search engine that facilitates the schedule and the speaker management. And for event-driven service interaction, you might introduce a message broker where your services can publish and subscribe messages to. And each of them is running on an environment that executes their software, the compute platform, which runs on a virtual machine. So now we have listed all the involved components, including their dependencies and their position in the value chain. The next step is to take this value chain and plot it along the evolution axis. So the first version could look like that we define to have the services in the custom-built evolution stage, and to use open source software for search engine, message broker, and data storage. And each of them is packaged as a container running on top of a cloud-hosted virtual machine. That could be the first version. And you are going to discuss it internally with your team, and you figure out, oh, well, to be honest, survey and ticketing, they do not really belong to our core domain. And in addition, we also have not really database expertise in-house. Instead, we would like to outsource it to someone else. So the next evolution step is that you can then, for example, use a product off the shelf, like survey and ticketing as a service, and move it from custom build to product and rental. And this also allows you to ignore all the related components that are depending on these both, because now the service provider is taking care of it. And for data storage, you can move, for example, we could decide to use a cloud-hosted database solution, so moving it further right to the commodity and utility section. So, and what this also allows you to do is to identify what components you would like to build in-house. That's Genesis and custom build. All those components that are located in there allows you to build it in-house. Or where to use or buy off-the-shelf products or use open source. And what component to outsource to utility suppliers. As I mentioned in the beginning, that microservices come with infrastructure complexities. So how can we now map all these infrastructure complexities? How can we map them out in Wardley maps? So, and we can discuss it in our team. And the first draft, or the first version that we are discussing could be, okay, let's use as much open source software as possible and custom build a part of the failure handling. So, for example, that we use for the Netflix OSS and as an example, or Spring Cloud as an example for service discovery, for load balancing, for centralized configuration management, and also for circuit breakers, and use Prometheus, Grafana, the AX stack, and Zipkin for the observability patterns such as metrics gathering, log aggregation, distributed tracing, monitoring, and so on. And, for example, Nginx as some sort of API gateway as a single point of entry from the outside. And we use this first version and discuss it internally again, and we figure out, oh, that's a lot to handle, because now the thing is that since we have to integrate all these open source software into our business logic, and it's pretty much visible to us as developers, because we have to integrate it. We have some parts we have to implement by ourselves. So it's not visible to our users, but to us as developers, because we have to integrate those. And we might decide now that's a lot of things to handle. Instead, we would like to offload it. For example, to offload it, some of the infrastructure components to a container orchestration platform. In this context, our microservices are packaged in a container that is orchestrated by a platform that's preferably running on top of a cloud infrastructure. So, and it allows us to abstract away some of the infrastructure components, such as service discovery, load balancing, centralized configuration management, scaling, recovery, and some observability components as well, and also external traffic routing from the outside as kind of like API gateway. So, and how does it look like now in a Wardley map? I'm sorry, I come back to that later. So I just wanted to give you some idea about like the overview of what kind of primitives are involved. So it's your containerized microservices that you package in a container, and these containers themselves are running in a pod. And a pod is a group of one or more application containers, and it can also involve a volume that's a shared storage, providing file system access or storage for storing your configuration or secret data. And also services that's kind of like abstraction layer which defines a logical set of pods and enables external traffic exposure, but also service discovery and load balancing. And your pods are running within worker nodes that are controlled by a master node. And one master node can run several pods. And the nodes themselves could be a working machine, for example, preferably a cloud-hosted virtual machine. A deployment is defining the desired state of how many replicas of your services shall run, and is responsible for restarting your services or replacing your services that have failed or that became unresponsive. So And an ingress is a component that allows you to route the external traffic from the outside to your pods and services inside the cluster. So now the question, how do these container orchestration look like in a Wortley map? So at first, as said, it abstracts away the infrastructure components for like service discovery, load balancing, centralized configuration management, scaling, recovery, and so on. So they become now less visible to us, to the developers. So they were moved down in their position a little bit. But a container orchestration comes with new primitives that we now have to deal with, like we have to configure pods, deployment, service, volume, ingress, and a lot more. So while the container orchestration is taking care of your infrastructure complexities, and they're getting less visible to us as developers, new primitives are coming into the scene that we have to deal with and becoming more visible to us. So we get our infrastructure complexities handled by the orchestration platform, which is great, but with the trade-off that new primitives come along and that we have to configure and to deal with. So the next evolution stage could be something that we decide when we discuss it again in our team internally, and we decide, well, okay, now we have our container orchestration, but we still have some of the application reliability concerns that still is residing in our business logic. And we would like to improve or to improve the operability of our software architecture by abstracting those away, like abstracting away the retries, timeout handling, bypass circuit breakers, and so on. And we don't want to deal with it anymore in our business logic. Instead, we might decide that we get this handled by a service mesh. So a service mesh is a decentralized infrastructure between our services that makes our service-to-service communication safe, reliable, and resilient. And it allows us to move the application networking reliability concerns to move it away from our business logic, which we have previously integrated as, for example, with Netflix OSS as open source tools. And it was polluted, by the way, because it wasn't a business logic, it was handling infrastructure complexities. So it allows us to move it away to a service mesh. A service mesh is logically split into a data plane and a control plane. A data plane is composed of sidecar proxies for each service, and it's running on top of Kubernetes, such as Istio. So Istio is one solution which is very popular. And the service mesh itself is running in the same pod as the service itself, and it's controlling the service and controlling the service-to-service communication along with a mixer, which is the mixer itself is guaranteeing to the policies and gathering telemetry, and the pilot itself is responsible for configuring your proxies at runtime. The galley is aggregating, validating, and distributing configuration within Istio itself. And the Citadel is a component which makes your service-to-service communication secure over TLS. So that's the one that issues and rotates certificates. So, and if we take the service mesh and now map it to a Wortley map, is that allows us to, that as you can see, that the timeout handling, the retries, circuit breaker, bulkheads, and so on, then moved now from custom build to product and rental, and they are now less visible to us as a developer because that's the service mesh which takes care of it. But also the service mesh, such as Istio, is coming with new primitives that we have to deal with and have to configure, so they're becoming more visible to us as developers. So while container orchestration such as Kubernetes and service mesh such as Istio are abstracting away infrastructure components and making it less visible to us as developers, that come with new primitives that we have to deal with. And we might, as another version, because it's an iterative process, we might to discuss it internally in our team, and we might end up with a decision, oh, that's still a lot of things to handle. We still have to configure all these primitives. And we would like to get all the infrastructure components handled by someone else by moving to serverless. So with serverless, you have no servers to manage or to provision, and you get your infrastructure fully managed by a cloud provider. And your work of unit now is not a container anymore, as described previously. Instead, your work of unit is now a fine-grained, short-lived function that is triggered by a variety of events. For example, an HTTP event, or a database event, or a file upload, or, for example, a schedule event, and so on. And your functions are automatically scaled dynamically by usage. And you only pay for execution. So when you have a function that gets idle, it shuts down and costs nothing. And serverless, for example, based on AWS, with AWS Lambda functions, come with core building blocks that you can wire together with your Lambda functions that are the functions in serverless domain. And just create a pretty short example. For example, the conference solution right now, just create a simple version of the CFP submission, call for paper submission as a speaker. So when I, as a speaker, would like to submit a call for paper, for example, in serverless, REST endpoint can be provided that is exposed by an API gateway, which triggers a function that creates CFP that takes this request, validates this request, and saves the talk details, the CFP details, into a DynamoDB table. And whenever a new entry comes into the DynamoDB table, it triggers a new function that sends an email to the organizer that a new CFP has been submitted. And the speaker also would like to upload a profile picture, and this could be uploaded to a 3-bucket directly. And whenever a new profile picture has been uploaded, another function could be triggered that updates the picture metadata into the database itself. The organizer would like to read this new CFP and calls this a function that retrieves the CFP details out of the database. And also, he would also would like to confirm the CFP. So another REST function is exposed that triggers another function, and it's on the one side updating the CFP status in the DynamoDB table, but also on the other hand publishes a message onto a SNS simple notification service topic that 2 other functions have subscribed to send out a confirmation email to the organizer, to the speaker that their talk has been accepted, or updates the talk details within the schedule management. And if the organizer would like to create a schedule, another function is going to be called that updates the schedule within the database. And whenever this database table has been updated, the search index could be updated by another function. You as attendee would like to retrieve the schedule, so then another function is another REST endpoint is going to be exposed by an API gateway that triggers the getSchedule function that reads the CFP, the schedule from the database, and delivers it to you as attendee. So this is an example of how a backend API and serverless technology can be implemented. And the function that they are containing your code, that's your business domain, that's your business logic. And all the other building blocks that are used for storing your data, but also triggering other functions and as wiring them, the functions together. How do they look like now in a Waterlay map? So now it's abstracted away from you because all the infrastructure components are now handled by the cloud provider, by a serverless provider, and it's not visible to you anymore. Instead, you are now dealing with functions and the core building blocks that you wire together to build your core domain. On top of that, you can also use pre-built common serverless components by using the serverless application repository, for example, that way you can publish and share pre-built and deploy pre-built common serverless blocks. For example, there could be already a pre-built serverless component that allows you to generate thumbnails, or there could be a pre-built common serverless component that allows you to update the Elasticsearch index. And with serverless technology in general, but also with a serverless application repository, it's this kind of efficiencies enable innovation, because now you have time that you can spend more on your business domain and delivering features to your customer that matters, and this enables innovation. For example, so that you can, that you can also add new features to existing product, for example, session rating, that you also can add comments, or that you can also create new components that, for example, that you add a new component for Q&A handling that enables new user needs. So to summarize, is that's very important to fulfill user and business needs and to focus on this one most, and focus on your core domain and build this one and how that differentiated from your competitors, and identify also those commodities that are not just differentiating you from your competitors itself, and continuously adapt. Because in the end, we would like to build a product that is usable and fulfilling user needs, leading to satisfied customer, and not a product that is expensive to build, took a long time, is not usable at all. Thank you.
Thank you very much, Susanne. That was a lot of information unloaded, but I really like it. It was super interesting. Do we have questions in the audience? Yeah, there's one. Wait, we're going to try this now properly.
Oh.
I mean, that's what it's built for, right? So let's... Can you pass it on? Yeah, thank you.
Okay. So the question is, with your worldly maps, to position, on this axis, there is this value chain, and is there any kind of positioning with importance of the object? Like some are more important than the others, but is there a way to position those in this graph, or they should be?
It allows you it's only for you an indicator what components might be more visible to your users, but it's also every component is visible on this axis, like going from visible to invisible. But it allows you to, for example, some of these that might be more invisible could be potential candidates that you can outsource later, because they could evolve more easily in the evolution axis. But they all have the same, I would say it depends on the components that you identify, but they might have the same, there's no that one is more important than the others. But I guess it's more that the visible components are the one that you should also strategically invest in most, but also the combination of both axes are very relevant to identify the component that you can outsource.
Okay. Awesome. Do we have another question? No, I have one left for you. I mean, as a consultant, you do this probably with companies every other day, right? So, I mean, in terms of introducing this and running this process, like how long does it kind of like take to do this discovery, and like what are the common obstacles?
So that's an iterative process. So it's whenever you do the first draft, it's just the other day it might look like something different, because you are evolving it with your own experience. It was just different inside. It's just a basic basis to communicate with the team, and it's never static. So you never end at a specific situation where now it's ready. Instead of, it's like you do it usually on a regular basis, where you look at your worldly maps, and it's continuously updated, and that you can evolve your tech stack along during the time and also with your experiences that you made. So it's never static, and it's kind of like a very iterative process that's up to you if you would like to do it once a month or even more frequent.
Okay. Yeah. Susanne, thank you very much.
Thank you.
Thanks for being here.